A massive container ship begins as something impossibly small compared to what it will become. The first step in shipbuilding is not mixing concrete or assembling a structure. The first step is designing the ship using sophisticated computer models. The ship's design determines every aspect of the final product. The hull shape, the interior layout, the engine systems, the structural arrangement, everything is modeled and optimized before construction begins. The design phase takes months. Teams of naval architects work to optimize the design for efficiency, strength, and cost. Once the design is approved, the actual construction begins. A ship that will become 400 meters long and weigh hundreds of thousands of tons is built piece by piece. The construction takes years. Thousands of workers are involved. The final ship is assembled from hundreds of smaller components, manufactured in different locations, and integrated together at the shipyard. Understanding how ships are built reveals principles of large-scale manufacturing, engineering coordination, and the remarkable logistics of modern shipbuilding. Today we're exploring how ships are constructed from steel plates to floating cities. The shipyard is a massive industrial facility. The largest shipyards cover hundreds of acres. The shipyard has multiple dry docks where ships are constructed. The shipyard has massive cranes capable of lifting hundreds of tons. The shipyard has workshops where components are fabricated. The shipyard has test facilities where systems are verified. The shipyard is organized to move materials and workers efficiently through the construction process. The layout of the shipyard affects the efficiency of ship construction. Shipyards are located near sources of steel and other materials. Access to water is critical for launching the completed ship. Access to transportation is critical for importing materials and exporting the finished ship. The major shipyards in the world are located in South Korea, Japan, China, and several European countries. The modular construction approach is the modern standard. Instead of building the entire ship in one location, the ship is divided into modules. Each module is a major section of the ship, perhaps the engine room module, the cargo hold module, the superstructure module. Each module is constructed separately in different areas of the shipyard or even in different workshops. The modules are built to precise specifications. The interfaces between modules are designed so that the modules fit together perfectly. Once the modules are complete, they are transported to the assembly location. The modules are joined together using massive welding operations. The final assembly creates the complete ship. The modular approach allows parallel construction. While one team is completing the engine room module, another team is completing the superstructure module. The modules are ready at approximately the same time. Assembly is quick because the preliminary construction is complete. Steel cutting is the first manufacturing step. Large sheets of steel are delivered to the shipyard. The sheets are cut to precise dimensions using advanced cutting technology. Computer-controlled plasma cutters cut the steel into the required shapes. The cutting is precise to within millimeters. The cut pieces are marked with identification numbers so that assembly workers know exactly where each piece goes. The precision of the cutting is critical because any dimensional errors will create problems during assembly. Steel processing involves bending and shaping the steel pieces. Some pieces are flat. Others require curves or bends to fit the ship's hull shape. Massive machines bend the steel into the required curves. The bending must be precise because the curvature of the hull is critical for the ship's hydrodynamic performance. Pieces are heated during bending to make the steel more malleable. Cold steel can crack if bent sharply. Heating allows larger bends without cracking. Welding is the process that joins steel pieces together. Modern ships use robotic welding systems. Robots perform much of the welding, but human welders work alongside the robots to complete welds that robots cannot handle. The welding is of critical importance because the hull integrity depends on weld quality. A poorly welded joint could leak or fail structurally. Welding inspectors examine every weld using ultrasonic testing and visual inspection. The inspection ensures that welds meet specifications. The total welding in a large container ship can exceed 100 kilometers of welded seams. The assembly sequence is carefully planned. The ship's keel is laid first. The keel is the structural spine of the ship. Additional structural members are welded to the keel to form the skeleton of the ship. The bottom and sides of the hull are attached. The interior structure is built within the hull. The engine is installed. The propeller and steering systems are installed. The ship transforms from a skeleton to a complete vessel as assembly progresses. The interior outfitting is the process of installing all systems within the ship. Electrical systems are installed. Plumbing systems are installed. HVAC systems are installed. Navigation and communication systems are installed. Furnishings are installed. The interior of the ship transforms into a functional living and working space. The interior outfitting can take months and involves hundreds of workers performing different tasks simultaneously. Quality control is continuous throughout construction. Inspectors check dimensions at each step. Systems are tested as they are installed. Welders are certified, and their work is inspected. The final stages of construction involve comprehensive testing. The ship is flooded to test for leaks. The engines are started and tested. The electrical systems are tested. The navigation systems are tested. All systems must function correctly before the ship is delivered. The launch is the moment when the ship is moved from the dry dock into the water. The dry dock can be a basin where water is pumped in, or it can be a slipway where the ship is launched down an incline into the water. The launch is carefully controlled. The ship must enter the water safely. The ship is launched using tugboats or by opening gates that allow water to flood the dry dock. Once the ship floats, it is guided to a fitting-out pier where final systems are installed and tested. The sea trials are the final test phase. The ship is taken to sea and tested under actual operating conditions. The engines are tested at various speeds. The maneuverability is tested. The steering is tested. The stability is tested. The ship is put through a series of demanding tests to verify that everything functions correctly. The sea trials can last weeks. Any problems discovered during sea trials must be corrected before the ship is delivered to the owner. The timeline for shipbuilding varies depending on ship size and complexity. A large container ship might take 2 to 3 years from start to completion. A smaller vessel might take 1 to 2 years. The timeline is compressed by the modular construction approach and the parallel work that occurs simultaneously. Thousands of workers contribute to the construction. The coordination of these thousands of workers is a complex logistics challenge. Schedules are maintained so that materials arrive when needed. Work is organized so that different teams don't interfere with each other. The cost of shipbuilding is substantial. A large container ship costs several $100 million. A smaller vessel might cost tens of millions of dollars. The cost depends on the ship size, complexity, and the labor costs in the country where the ship is built. South Korea and Japan have high labor costs but advanced technology. China has lower labor costs and has emerged as the largest shipbuilder. The choice of shipyard depends on the owner's priorities regarding cost, technology, and delivery timeline. The environmental impact of shipbuilding is a growing concern. Shipyards use large quantities of materials and energy. The cutting, bending, and welding produce waste. Modern shipyards implement waste management systems to minimize environmental impact. The ships being built are increasingly designed with environmental considerations. New environmental regulations require ships to be more efficient and less polluting. The shipyards are adapting to these requirements by implementing new technologies and processes. Automation is increasing in modern shipyards. Robotic systems perform welding, cutting, and other repetitive tasks. Automated systems improve efficiency and consistency. However, some tasks still require human workers. The integration of human workers and automated systems creates a hybrid workforce. The workers operate and maintain the automated systems. The automation increases productivity while human workers focus on tasks requiring judgment and flexibility. The innovation in shipbuilding is continuous. New materials are being tested. New construction methods are being developed. Computer modeling and simulation allow engineers to optimize designs before construction begins. Virtual reality is being used to train workers and to plan complex assembly sequences. 3D printing is being explored for manufacturing some components. The future of shipbuilding will likely involve even greater use of technology and automation. The shipyard workforce requires specialized skills. Welders must be certified and highly skilled. Electricians, pipe fitters, and other tradespeople must meet high standards. Engineers must understand complex systems. The training of skilled workers is a long process. Many shipyards operate training programs to develop the next generation of shipbuilding workers. The scarcity of skilled workers is a challenge for some shipyards. The supply chain for shipbuilding is global. Steel is sourced from multiple countries. Engines are manufactured by specialized engine builders. Electrical systems are manufactured by electronics companies. Thousands of components are sourced from suppliers around the world. The coordination of this global supply chain is complex. Delays in one component can delay the entire project. Modern shipyards implement sophisticated supply chain management systems to minimize delays. Understanding how ships are built reveals the remarkable complexity of large-scale manufacturing. A container ship is essentially a city on water. The construction requires thousands of workers, hundreds of suppliers, and years of coordinated effort. The precision required is extraordinary. The management of the logistics is sophisticated. The result is a vessel that will operate reliably for 25 or 30 years, crossing oceans thousands of times. The shipbuilding industry represents one of the most complex manufacturing operations in the world. If you're fascinated by how large-scale manufacturing coordinates thousands of workers and complex supply chains to create extraordinary structures, subscribe to the channel. We regularly explore how engineering and logistics combine to create remarkable achievements. Understanding shipbuilding reveals principles of manufacturing, engineering, and coordination that apply far beyond maritime operations. Your subscription supports the creation of content that explores how humans organize to accomplish remarkable feats of engineering. Thank you for watching and for your interest in understanding how ships are built from steel plates to floating cities.